Imagine your car needs a new part. So a smart machine scans the broken piece, designs a perfect fit, and a 3D printer prints the exact piece you need. Now picture cancer care doing the same thing. We can scan the tumor's DNA, next-generation sequencing, RNA, transcriptomics, immune profiling, and spatial biology over 1,000 plus data points. And AI, along with physician intelligence, because you have to use both, can pull from various hallmarks of cancer and generate the exact treatments targeted for you. Whether it's a drug or something that isn't even currently available, an off-label repurposed drug that's right for you, or an integrative natural agent or a plant or an immunotherapy that has to be designed for you. This is the future of oncology. So what's the best way to deliver care once you have that information? It's knowing things like stromal barriers and how to change the tumor's microenvironment around the tumor so that the immune system starts to work. This is where we're going. This is generative oncology or precision oncology, because that's where we're moving. The data combining with the science and retraining physicians to be able to use this in their practice and help patients. This is the very difference between great responses and sometimes mediocre ones. This is very different than the double-blind placebo clinical trial model that's a one-size-fits-all pharma-driven program. Instead, today we're going to talk about generative oncology, a better way to understand precision oncology, how it's growing, how it works, and how it's transforming care. I'm Dr. Dino Prato, and for the last 25 years, my team and I have helped thousands of patients who have failed the top cancer hospitals across the country. And we've done this by getting rid of the guesswork and really mastering precision care, using the latest technologies to help target cancer. So today in this episode, I'm going to show you the power of precision or generative oncology, how it works, going beyond what you might think. So here's a big idea. Generative oncology means we're using thousands of data points, actionable targets instead of just a few that we have today. It's extremely different. Today you might have 20 markers, a tumor marker, a biopsy, imaging, that's it. Versus imagine transcriptomics, thousands of genes, next generation sequencing, hundreds of genes, immune profiling, spatial biology. And when you combine all of this, you have 1,000 plus data points that lets you see the heat map of what's driving the cancer. What are the hallmarks to your cancer? What's making it grow and spread? What's making it resistant? Why is the immune system not working properly? What's the programming inside the cancer that's causing it? Now, some people are stuck on just the metabolic theory of cancer, which is one part of it, but it's not the whole picture. As I've always said, there are two parts, and you can see that when you really understand precision oncology. There's a metabolic side, that's important, we don't want to ignore that, but there's also a mutational side, it's called bimodal. And when you go to treatment, you need to understand resistance of the immune system, because the first and last defense against cancer is immunity. That's how you provide better care. This isn't science fiction, it's already happening. We're seeing so much of the matching of medicine make such a difference for patients. And when we can do that, we can give micro doses and we can avoid side effects and help people have quality and length of life in really all stages of cancer. The key here is targeting. And we're doing that right now. And you can see that with studies like iPredict, where they showed already just in that simple study where they were using DNA, 20+% better care and outcomes. In the winter trials with RNA, they showed another huge improvement in outcomes. Now imagine those are just DNA and RNA. Now imagine combining that with on-label, off-label, nanoparticle phytotherapeutic plants, and combining that with oxygen therapies and targeted care and immunotherapies that are custom designed, even building cellular vaccines from your natural killer cells and dendritic cells. By comparing each patient's progression and match therapy versus their prior treatment, we can see a huge difference. Here's a simple example. We'll use the fictitious patient Marco. His scans looked like many others, but his tumor biology was very different. Same type and stage of cancer, but totally different heterogeneity. His DNA, RNA testing confirmed very different markers, and his heat map showed louder pathways for his tumor. His immune profiling and targeting allowed for us to turn his cold tumor hot, fix his pathways, and with lower dose targeted care with virtually little to no side effects, he was able to bring a late stage metastasized cancer into remission. This is the power of precision oncology. This is the work that brings better care month by month. The data collects and the technology improves. And this is what our team has been doing for 2.5 decades. Deep mapping and cancer care are so important. So let's use this analogy. DNA is like looking at a city from above, and you can see somebody driving the car, which is the DNA, and you can see where where they are and what are the drivers to the cancer, the mutational breaks, and the treatment targets. The RNA show us the streets, where the resistant pathways are, how to block those. And the immune system tells us what's blocking the immune system from working. And as I've said before, you have gangs around the tumors that are blocking the police of your immune system from just getting rid of it, which it does it every single day. So how do we turn these things on? The key is the data and the heat maps, understanding what these pathways are, and then creating the unique care for each patient to turn this around. This is the future of cancer treatment. We're already doing it, and it's happening at many levels across the world. It's going to really improve patient outcomes. From data to custom design. We're not just collecting data or putting people into clinical trials. We're linking their individual markers and their heat maps to develop an N of 1 treatment plan custom for them, everything built on the patient. This is where Generative shines, or we'll call it precision, because we can move faster. With multi-omics testing and heat maps, we can assemble the treatments, custom make them, and deliver them in a unique way to help each patient. This is so important without causing harm. That's the goal, with better quality of life. Because remember, only 1 or 2% of the IV chemotherapy that most patients use makes it to the tumor. Where's the other 98% going, or 95% for that matter? Going to affect the organs, the central nervous system, cause side effects? We don't need that. With precision, we can be right on the spot. We can use repurposed and advanced therapeutics, nanoparticle delivery. Yes, we can even go after medicines that are off-label that might be right targets for the patient, like ivermectin, methylene blue, menbendazole, all these popular agents, but it's not a one-size-fits-all because it depends on your markers and your heat maps. And there are many other repurposed drugs that can be selected as well. There are hundreds of older approved medications with mechanisms that work in your pathways. Pharmaceutical companies aren't interested in these because they're older, they're inexpensive, they're not as exciting as the new sexy smart drugs that cost billions of dollars. These have to be typed, and it's really in the work of the physician to understand how to use them as adjuvants in therapy. Cellular biologics expand your immune system, your natural killer cells and dendritic cells, giving them the right DAMPs, damage-associated molecular patterns and messaging and peptides, so your immune system can do the ultimate job of killing the cancer. That's the key. Your immune system is the first and last defense against cancer. We can also build personalized vaccines, nanoparticle phytotherapeutics to enhance these mechanisms, target the cancer stem cells, improve the targeting, remove the resistance, reduce the toxicity. That is the ultimate goal with precision oncology. Many of our drugs were originally developed by plants anyways, but what about all these wonderful plants? Just the bioavailability isn't there, so we can increase that. AI is helping with this precision oncology, and here's how. It allows us to look at so much data at one time, refine the data, heat map it, help us to build the plan, and then physicians to really finalize the diagnosis and care with so much of the work being done. Crunch these complex pathways to find lower toxicity sweet spots for each patient and give patients a massive advantage. This progress has accelerated enormously. Years ago, we did this at a much slower pace. Now, we're using multimodal approaches, understanding metabolism, mutation, resistance, and immunity. Not all cancers are simple. It's easy to think one treatment works for everyone, but it's just not the case. This approach allows us to target care for each person, personalized for each individual. This is where we're headed in technology, and it's very exciting. I'm happy because we've built the ecosystem, and I can say this, we are one of the world leaders in this space, and we're excited about that. We've already seen this framework work so great for our patients and improve. We're doing this now at an accelerated level. Labs, pharmacies, custom drug design, custom delivery, minimally invasive procedures with guided care that's precise for each patient. It's not just about gene editing. Everybody thinks it's going to be the new CRISPR gene and it's going to do the editing and change cancer. It's not going to be that simple. It's about finding the right targets for each person and doing them in a non-toxic way so they can get back to life and go into remission. That's the goal of precision oncology. When you think of AI in the world of precision oncology, it's not about replacing doctors. It's about empowering them. Doctors need training in precision, understanding molecular pathways and integrative strategies. Every time a physician joins our team, whether they're an oncologist, primary care doctor, a naturopathic doctor, they need 2,000 hours of training in precision oncology, about a year, to get up to speed. And this helps them to ensure they understand precision and targeting and combinations, because that's what it takes to move in today's world of complex cancer treatment planning. It's not a one-size-fits-all. So this is a very exciting time in our history, and it's such a blessing that we're moving into this. I see a time where cancer is gone and going away, and we're able to effectively treat it with minimal toxicity to patients. I hope this was helpful, and may the Lord bless you on your journey to healing.